Lesson 3. We'll be talking about inheritance and enemies. So for a brief reminder on the code of conduct, please be respectful, use your full name, turn on your camera, and keep side chatting to a minimum. All right, let's go into an overview of what we're learning today. So we're going to be going over a review of conditional statements, and then we'll learn about three things: inheritance, array lists, and enemies. So first, let's review some conditional statements. If statements run a block of code if a specific condition is true. So for example, if is Saturday, then it's going to print out go to the beach. Else, if it's Sunday, then it's going to print out go downtown. Else, if neither of those are true, it's going to print out go to school. Boolean AND statements. So if we say Boolean and Boolean, then both things have to be true. For example, true and true is true, but false and true is false because both of them have to be true. So whenever dealing with AND statements, just ask yourself, are all of the Booleans true? Now let's give a real-world example. So if I wanted to make a cookie clicker game, I could make it so that the user has to have their mouse on top of the cookie and they have to be clicking the cookie. In code, we could represent this as something like mouse is on cookie and user is clicking cookie. This is different from Boolean OR statements. So if we say Boolean or Boolean, only one of them must be true. So for example, false or false is false, but true or false is true. So whenever dealing with OR statements, just ask yourself, is at least one of the statements true? So for a real-world example, let's say I only want to go outside only if I don't have homework, or it's a weekend. In code, we could represent this as something like has no homework or is weekend. Finally, Boolean NOT statements. So if we put not or an exclamation mark before Boolean, it becomes its opposite. So not false is just true, and not true is just false. So for example, not true and true is false and true, which is false. For a real-world example, let's say we want to make a game and we want the game to be over only if the user does not have any health left. In code, we could represent this as not has health. Let's go on to some Boolean exercises. So once you know what the condition evaluates to, in this case, you're not going to put the answer in chat, so I just want you to pause this video and try to figure out on your own. All right, hopefully you've had the time to figure out the answer on your own. So let's go over the solution. If Boolean falafel equals false and Boolean tomato equals true, then we have an if statement here, tomato and not falafel, or falafel. So this is essentially true and not false, or false. So that's true and not false or false, true or false, which is true. Now let's move on to inheritance. So inheritance allows one class to inherit the properties of another class. So for example, variables or methods, etc. So right here, for some examples of inheritance. In inheritance, a child class extends a parent class and inherits its properties. So if dog extends animal, then it will inherit the properties of animal. That means dog is an animal. The superclass or parent class is animal and the child class is dog. Multiple classes can inherit one class, so class cat could also inherit animal. You can think of animal like an overall category and cat and dog, the child classes, as individual types of that overall parent class. So here we have class animal, and then we have class dog extends animal. So because it extends animal, it's automatically going to inherit string name and method eat, even though it does not actually define them right here, because since it extends animal, it automatically has all of these variables and methods. So let's have some practice. What is the output right here of this main class? So here, or this main method. So right here, we have class car, and it has string name, int year, and method get info. Next, we have class truck, which extends car, so it automatically has all these methods. So we have int weight, additionally, which is only in the truck class and it is not in the car class. And we have get weight, which is a method, and again is only in the truck class. So given that, pause the video and try to figure out what get info and get weight are going to output. All right, let's go over this. So when we call get info is only in the car class, but because truck extends car, it automatically inherits this get info method. So it's going to print out the name and the year. which have been set to Mater 1957. Next, getWeight is going to print out 3200 because that is a method in the truck class. So Mater 1957 and 3200. Cool. Now let's go on to super. So in Java, it automatically creates an empty constructor for the class if you don't actually create one. However, if you do create a constructor in a child class, you need to call super, the constructor of the parent class, in the first line, and pass in the necessary variables in order to initialize the variables that were inherited from the parent class. So let's get this example. Once again, we have class car, and then we have class truck. So right here we have a car constructor that takes string A and int B and assigns them to the name and the year. Next we have truck, which inherits name and year and also adds int weight. So in this constructor, we're going to take in string A, int B, and int C. Since we want to initialize name and year, but name and year weren't actually defined in this truck class, we're going to have to call super in order to initialize those inherited variables. So super of A and B is just replaced by public car of A and B, which is going to set name equal to A and year equal to B. And then since we've defined int weight directly in the truck class, we can just directly assign that to the value of C. Next, let's go over overriding methods. So creating a new method with the same name as one in the parent class will override the method or replace it. So what we'll call in getInfo from a truck object output. I'll give you a second to pause this and try to figure out on your own. All right, so let's look at these two classes. Class car defines getInfo as name plus year. Truck defines getInfo as print out the year plus the name plus the weight. So as we know, if we define something in a child class and a parent class, the child class method is going to override the parent class method. So in this case, it is going to call this getInfo method with year, name, and weight. So it is going to print out 1957, Mater 3200. So why do we actually use inheritance? Well, inheritance makes it so that you don't need to reinitialize variables or repeat methods. You can simply inherit the variables and the methods. So, for example, if we had a boss class with different types of bosses extending the parent class, then all of the boss child classes can inherit variables such as x, y, and health, and methods such as attack and move. These are going to be methods and variables that all of the bosses have. But each of the bosses can, for example, have a method called special move, where they do something unique to that specific child class that isn't inherited by all of the other bosses. So that's a great way to save a lot of time while inheriting all of the variables and methods that all of the different bosses have. Now let's go into adding enemies to our Space Invaders game. So, no, this looks like a lot, but essentially what you're going to do here is you're going to create an enemy class, and you're going to add the following methods and variables implementing drawable. So you're going to say in class enemy implements drawable. So first, let's go into the instance variables. You're just going to define them you're just going to initialize them. So int x, int y, int width, int height, etc., for all of these instance variables. Then in the constructor, you are going to actually create a constructor, and all it's going to take is int x and int y. So obviously you're going to assign the value of this x to int x, the value of this y to int y, but then for all of these other ones, they're just going to have default values that are set up. So for example, 70 is recommended for width, 50 is recommended for height, Boolean visible is going to be initially true, and so on. Then you're going to define some methods. So you're going to have set x, set y, set velocity x, set velocity y, get velocity x, etc., And you can see the definitions for each of these methods right here. So I'm going to give you some time to pause this and try it on your own. If you get confused by anything, don't worry, we are going to go over the answer in a second. All right, hopefully you've had some time to create these instance variables, constructor, and the methods. Now we're going to go over the fast enemy class. So we are going to create a fast enemy class that extends enemy and implements drawable. So your only new instance variable is going to be speed multiplier, And you're going to have a constructor, which is just fast enemy, and then you're going to have int x and int y, but you're also going to have int speed multiplier. So first you're going to call super of int x comma int y in order to initialize those variables in the parent class of enemy, and then you're going to directly initialize speed multiplier because that's something that wasn't inherited by enemy and you actually need to directly define it. The only method you're going to be creating is move. So you're just going to override the move method in the enemy class and change the position by the velocity and the speed multiplier. It changes the velocity y if it reaches the top or bottom of the screen, and reset x if it reaches the end of the screen. So please pause this video now and try that on your own. Alright, now let's go over the answer. So here's an answer key. Alright, right here we have the enemy class first. We can see that we're creating all of these instance variables right here, and then over here we are creating this constructor and initializing all of these instance variables. Then we have all of our different methods in the enemy class right here. Cool. Next, we're going to have the fast enemy class. So we're creating speed multiplier, and then we're creating our constructor right here, which takes int x, int y, and int speed multiplier. So all you have to do is do super of x comma y, and that is going to automatically call the constructor to initialize all of the instance variables in the enemy class, and then all you have to do directly is instantialize the speed multiplier right here directly. So this is a super short constructor because you're just doing all of the work by calling the enemy class one more time. And then you're going to go on to overriding your move method right here. All right. Now let's move on to array lists. So we're going to use array lists to create multiple enemies. So how do you create an array list? Well, first at the very, very top of your program, you're going to say import java.util.arraylist. And then the format for creating an array list is you're going to say array list and then these less than or greater than symbols. And inside you're going to put the type name equals new array list type, 2 parentheses, and then a semicolon. These 2 parentheses is because this is actually technically a constructor because you're constructing a new array list. Now, what is type? Well, type in this case is whatever type of class you're initializing it as. So for example, if I wanted to make an array list of, let's say, cars, then I would say array list car name equals new array list car. And the benefit of array lists as opposed to arrays is that there are no set size, so you can remove and add items as needed. So in arrays, you have to automatically set the size. Like for example, I want to have an int array of exactly 5. But for this one, you can create an array list that is completely empty. It has absolutely nothing at all inside of it. And then you can add things as you go. So you don't need to know how big your array list is going to be when you start off creating it. So here are some methods that you can use with array lists. So you can say .add and element, that's going to add whatever element to your array list. .remove of index, that is going to remove the index, that is going to remove the element that is at that index. .get index is going to return the element that is at that index. .clear is going to automatically get rid of everything in the array list and set the size equal to 0. And then .size is going to return the size of the array list. All right, let's give an example of using some array list functions. So first we have this example. We have array list of string, r equals new array list string. So that's an example of a type. And then if we have r.add Kate, r.add Drew, we're adding all of these people. And then if you print out the array list, it's going to print out Kate, Drew, Mark, and Brian because we added those 4 people right here. Then if you say r.remove 1, it's going to print Kate, Mark, and Brian because it removed Drew. If you may recall, when we remove at 1, the index 1 is actually the second element, so it removed Drew instead of removing Kate. Then if you say system.out.println r.get1, that is going to return the new element at index 1, which is going to be Mark. And if you print out the size, it's going to say 3. Next, if you do array.clear, it's going to set the array equal to 0. So as you can see here, it has nothing inside of it. Now let's go on to ArrayList iteration. So you can use a for each loop to iterate through ArrayLists. So for example, if you create a new ArrayList and then you add 1, 5, and 6, then you can say for int num in nums system.out.println num. So all this is saying is it's saying go through every single element in this ArrayList in order and print out that element which I've named as num. So right here we can see that in this for each loop we're going to print out 1, 5, and 6 because that is the contents of this ArrayList called nums. And notice how we said integer, capital I integer instead of int. That is because ArrayLists only work with objects. So technically ints are actually primitives. So because they're a primitive type instead of being an object, we can't actually just put them directly in. Because then, for example, if we were trying to use, let's say, array.remove, and then you put 1 inside the parentheses, they don't know whether you're talking about the element that has the value of 1 or the element at index 1. So instead, you're going to say integer, which is just a class version or an object version of an int. So now let's go on to applying this to our project. So ArrayLists of enemies. To later draw our enemies, we're going to need them in the screen class. So in the screen class, you're going to create an ArrayList of 2 enemies, create an ArrayList of 1 fast enemy, and you can have the enemy start at a random y position. So these should be instance variables, and right now you will only have 1 fast enemy, but later you will be adding more. So these instance variables, for example, you might say ArrayList enemy. We could name it maybe ArrayList enemy enemies. And then we could say ArrayList fast enemy fast enemies. And those would be the names of the instance variables that contain the ArrayLists of enemies and fast enemies. That way you can access them easily throughout your program. And here's some reference code. So I'll give you some time to pause this video and do this in your own project. All right, hopefully you've had some time to do that. We're going to move on now. So now let's go on to drawing enemies. So to draw the enemies on the screen, you call the drawMe functions of the objects in a for each loop, going through the ArrayLists of the enemy and fast enemies separately. So here's some reference code. So you can see this is how we do paint component. You pass in graphicsg to the method, and then you're going to call paint component in the superclass, and then you're going to say car.drawMeg. So that's an example of how we might paint a car. Next, here's some reference code for each loops, using for each string in ArrayList or array names, you're going to print out the string. So I will give you some time to do that now. Please pause and try it on your own. All right. Let's go over the answer key. So in screen.java, you're going to go down here, and you can see in this paint component method, you're going to pass in graphicsg, you're going to call super.paintComponentG, and in this for each loop, you're going to just call enemy.drawMe of G. If you need more time looking at this class, feel free to pause the video, and I will slowly scroll so you can look at the entire class as well. All right. So that is it for today's lesson. I hope you enjoyed Advanced Java Lesson 3, and I'll see you for Advanced Java Lesson 4.